since it's just a review for the test coming up this weekend, I figure we'd just go through all of them together, even if we've done them or haven't. That way, we're make sure everybody knows it. So I guess I'll start. Number 2 just says, given a 90% confidence interval of 45 to 150 for mean heart rate, which of the following is the best interpretation of this confidence interval? I said that we're 90% confident that the true mean heart rate is between 45 and 105.
Yeah, that's what I got.
Yeah, that's what I got.
All right, awesome. Number 3, I guess I can read it.
I did the central limit theorem. Is that right?
I actually haven't had a chance to go over it, so let me read it real quick.
Oh,
I actually put, oh yeah, go ahead and read it, and then I'll tell you what I put. I put a different answer though.
All right. What'd you get?
So I said, yes, the distribution of the mean for each sample is normal since the data have been determined to be normal.
Okay.
Because it like specifically states that the QQ plots are normal.
Oh, that's like the question yeah, that's the same question basically as our
Right.
yeah, the one we did like 2 days ago.
One of the requirements of QQ plots is that it's normal.
Normal.
Okay.
I don't know this one. I'm gonna look it up.
Are we still on 3 or did we move on to 4?
4.
We're on 4.
Okay. Wouldn't it be a confidence interval for the mean of differences using dependent samples?
That's what I thought.
Shelby, is that what you put?
To be completely honest, I just kind of guessed on that one because I really didn't know.
Okay.
So yeah, that one sounds great.
Okay.
Well,
okay. For number 5, I put I don't know if this is right, but I think it's compute a 99% confidence interval rather than a 95, or yeah, that one. Is that right, or?
let me read it real quick.
I don't think obtaining the savings account balances of only 10 customers would make sense. I don't think changing the sample would help.
I think it's obtain the balances of 90 bank customers rather than 30.
I think you're right.
Because I think the larger the sample is, the smaller the margin of error is.
See, I thought that too, but I think it might actually be to compute a 99% confidence interval because it's asking what produces a smaller. Oh, never mind.
Margin of error.
Yeah, I read it
So
wrong.
that's either going to be to obtain the balance of 90 customers.
Yeah, I just read it wrong.
But I think it's obtain the balance of 90 customers.
Yep, I
Yeah.
got it.
Okay, cool.
Yeah. Y'all think it's in the balance of 90 customers?
Yeah.
Oh, with a smaller margin of error.
Correct.
Yeah, that totally makes sense. Smaller margin of error with a larger sample, right? Okay, yeah. Yeah, that makes sense now.
Yeah.
But wait a minute. So just one question. So just to make sure I'm not missing this, computing a 99% confidence interval
Mm-hmm.
would just be adding more people to the sample, or is that right, or am I just...
No, the confidence interval is the width of it depends on the confidence level, so the 99 or the 95, as well as the sample size. So by saying that you have a 99% confidence interval means that you're 99% sure, basically, that it's between the numbers you chose.
Oh, okay. Yeah.
You
Perfect.
increase
Yeah.
that, the smaller the margin, by either having more people, more sample, or by lowering the confidence interval.
Yeah, I'm sorry. I'm thinking on the bell curve, I'm thinking for the 95, you've got 3,400 and 4,100 on each side, and then you're extending, but it's, yeah. No, that's right. Okay, sorry.
Alright. I guess we need to pull up the applet for this one. .960 is the z-score, by the way, if you don't have that lesson open.
Great. Even my Microsoft, like Excel and Word, like when I try to open them, they it says it can't send some to the program, and then it like freezes, and man, I hate this thing. My old Beast computer worked, but this thing does not work very well. Anyway.
Did you guys finish that one, or are you still working on it?
I haven't even started
Okay,
with this thing.
no worries. be right back while you work on that. Give me just
Great.
a few seconds.
Yep. So I think it's D, but I may have calculated it wrong. So 1002.576 and 997,424.
That's the same one I got. So, what did you get, Alexis?
Sorry, I just got back on here.
6.
All right.
Which one did you get, Shelby?
I got the last one. I mean, I don't know if it's right, but
The 997.424.
yeah.
Yeah.
So how'd you get that? Because that's not what I got.
Neither of you. Wait, Brandon? What did you get?
I got the 99840 because it's the 1000 minus Z, which is 1.96, times the.
I put it into the Excel sheet.
Okay,
That's how I got it.
I see. Because I just calculated it with the in lesson 10, the equation there.
Yeah.
So let me open up the Excel sheet real quick, since I'll need to anyway. And you just did the one sample t-test with the mean, standard deviation, and n.
Yeah.
A second.
I'm still not getting that same. Did you have?
What did you get when you used the Excel? The same thing?
No, I get 996, 818. I've got for the mean on the one sample t-test. The mean is 1,000, standard deviation is 2, and then n is 4.
And you
Alright.
got 996.
Hold on, just a
996 and 1003.
How did you do it, Alexis?
I used the Excel. Let me get it.
I can't. I don't remember exactly which sheet I used, but I know I used Excel to find that answer.
Okay.
Hold on, I'm a little off here.
How about we just come back to this one because we've been on this one for like 10 minutes now.
Yeah. Hold on, I think I almost got it. I'm almost. Let's go to a different question.
All right.
I'm gonna just go with 996 actually. I don't know.
Okay, let's just come back to this one.
Yeah.
All right.
Like I said.
And looks like 7 is basically the same thing. No, a little. Man. I have no clue.
So for this one, the sample size formula is n equals z times the standard deviation divided by m squared. So the standard deviation is 0.01, the z is the 1.96, m is the margin of error.
Okay. Anyone have a calculator close by, or?
Go to wolframalpha.com.
Oh, I hate that web. They email me too much.
Go to the bottom of the emails and say you don't want more emails.
Oh, I didn't see that. She emails me. It's like a lady emails me like once a week, man.
All websites that email like that are required to have opt out.
Okay. Yeah. All right.
So I got 38416.
1 second, I'm almost done with it. Yeah, I got that one too.
Perfect.
Can you
Alright,
send
yeah, that's what I got.
Can you send me the exact link you have, Brandon, for the Wolfram Alpha? Like, I'm looking through it and I don't know.
Wolframalpha.com.
What? Yeah, and so you just type in like confidence interval.
No, you type in the equation. So you just copy, I'll send it to you.
Oh, snap. I see what you're saying. Okay. Never mind.
Type that in, and it's a calculator.
Nice.
Very
Perfect.
good calculator.
Sweet. Okay. Man, I should have paid more attention to that in the beginning. I just use this hand calculator and it takes forever and I always get the numbers wrong, so. Cool.
Alright, so for 8, I got the first one, where the null equals 1250, and then the alternative is less than 1250.
Yep.
I
I
put-
agree.
Yeah, that's right.
Okay.
Okay?
I'm just joking. For number 7, you got 1960, is that right?
No, 38416.
38416, sorry. Okay, I wasn't listening. All right, number 9. A statistical test of hypothesis. We can say that data is significant. At
So
level.
9 is the p-value is less than a.
Yeah.
Yeah.
Did you guys see that meme that I posted on the discussion board?
I did not.
Okay, cool. I'll send it to you. All right, number 10. Um, I mean, I would think yes, right? Like, oh wait, sample size of 15 from each of the four. Oh,
I said yes, they have a total of 60 GPAs and all, so they can apply the central limit theorem.
Yeah, it would make sense. I agree.
Okay. Has everyone read 11 yet?
I'm currently reading
I'm
it.
reading it.
Isn't that
I forget, what are the two different types of errors?
type 1 and type 2?
Yeah, but which
If you
one?
look in the individual preparation, there's a link to the online book, and in the summaries, it has the explanation.
Oh, it does? Okay.
Yeah. So it's type 2, right? Or no, hold on.
I said type 1.
Type 1, yeah. It's type 1. Because they reject the null and then
Yeah.
it's
yeah, they decide on a maximum p-value for which they will reject the null hypothesis.
Okay, so type 1 and we're on 12 now, right?
Yep.
I believe
Okay.
so.
Yep.
So isn't it by reducing the probability of committing a type 1 error, we increase the probability of committing type 2?
Correct.
Well, that's what I said.
Okay.
Okay. So for number 13, I don't believe it's C.
No, it's not C. It'll be either B or D.
Yeah.
I'm thinking B. What do you guys think?
Well, you need to calculate the p-value. Which formula are you guys using for this?
I don't know. I need one of those not a Venn diagram. It's the I get so this messes me up. Like fail to reject or reject.
It's just based on if the p-value is bigger or smaller than
The
the.
level of significance.
Yeah, I couldn't think of the word.
Yep. Do you guys have? Are you guys getting it?
I said it's D, but I don't know if that's right.
Okay.
Wait, don't you can use that Excel for this, right?
Well, like a t-test, right?
I think it is a t-test.
All right.
Okay, I got a really small p-value. I don't know if that's right.
Did you get 4.54 e to the 97?
No.
Okay.
I got a small one, but it wasn't that.
I had the wrong 0.04. I hadn't changed the null hypothesis.
Oh, okay.
So I went to the one sample t-test, put in the mean as 1.53, standard deviation. Actually, it should be, yeah, 1.53. Standard deviation of 0.17 and n of 100. 95 confidence interval and a null hypothesis of 1.5. Is that what you guys did?
Yeah.
And then got 0.04.
For your p-value?
Yeah,
Did you put the type of test as greater than?
I did put the type of test as greater than.
Hold on. I'm a little bit behind you, but almost there.
Yeah, I got the same thing.
Okay.
So it would be reject the null
I believe so, since that's
because
less
it's smaller.
Yeah. Yeah, that's right.
buddy.
So independent.
I think so.
That's what I said.
Okay.
What was the p-value for the one y'all did? We just did a minute ago.
What?
What was the p-value we got?
0.043.
48614. Boom. Okay.
For 15, I said independent sampling. The brother and sister are separate people who make their own choices.
I put dependent sampling because if you select a brother to compare to the academic achievement, blah, 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 blah.
Yeah. I mean, that makes sense, but like the reason I put what I put is because like the the last part, it says, so the brother's academic achievement shouldn't depend on his sister's academic achievement.
Mhm.
Yeah, but then like in the middle of like the paragraph at the top, it says they have to be raised in the same home. So it's going to be dependent, I think, because like choosing a brother, that helps you know what like sister would be in the other group.
Okay.
Do you know what I mean?
Yeah.
I don't know if that makes sense, but
I know it does.
okay.
And so we're going with dependent sampling on that
Yeah.
because it's in this. Okay. And I'm sorry, really quick, I just want to make sure for number 14, what'd you guys put?
Independent.
Okay, just making sure. Great. Thanks.
And then for the next one, we're saying, are we going with the independent since they're different?
The dependent.
Dependent? I'm gonna look that up just in the reading just to make sure. Unless you guys already did, because I can see it both ways.
Yeah.
Okay, so in contrast to dependent samples, two samples are independent if knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2.
So it is
yeah,
dependent.
yeah, I would say that is dependent.
Okay.
Time to open the data file.
Number 17 is A.
I got D, but we're on 16 still.
Okay.
This is the one sample t-test, right?
Yeah. Number 16. Oh, okay.
So this would be the confidence interval for you when standard deviation is unknown, right?
That's what I said.
Yeah.
Alright, and then for 17, I got D.
Yep.
So it's the 11.168.
Yep.
Oh, hold on, guys. Hold on. Okay, perfect. Yep.
All right.
11.168.
Okay, so then 18, confidence interval for the difference of means using independent samples, right?
I believe so.
So the last one, right?
Yeah.
Okay.
Just 16, you got what?
The confidence interval for difference of means using independent samples.
Okay, perfect.
Wait, did you ask for 16 or 18?
18.
Okay, I heard 16, so I just want to make sure.
No, I said 16.
Oh, well, that was
Well, that
8.
was 18.
Okay. And then 16 was what again?
The confidence interval when standard deviation is unknown.
Did anyone do 19 yet?
I am working.
Yeah, I did.
What'd you get, Shelby?
Two
I got
sample
negative
tests,
423.
423.
Yeah.
Okay, I'm still working on it.
Oh my gosh, I hate this computer. So I just had this thing pop up. It's like change your password, and then I accidentally clicked save for later, and like on the whatever I learned. So this is kind of driving me crazy. You got what again for 19?
Negative 4.423.
423. Great. Thank you.
It's the 2 sample t-test, right? Or is it the paired sample t-test?
I think it's a 2 sample.
I did the 2 sample, yeah.
That's what I thought. I got the same answer. I just wanted to make sure I put it in
Okay.
the right spot.
Alright.
Because LA and New York.
Okay, so 20 is ANOVA.
Yep.
Yeah, like this was the same problem. We already did this problem, right? Something about bone density, right? I don't know. Whatever.
And 21 is 7.978.
Yep.
And 22 is 0.002.
Man, y'all are fast. I can't even click it as fast as y'all are talking. I don't know how y'all are. Did y'all already do this?
I did.
No,
Oh,
I didn't. But
All right.
And then 23 is there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups.
yep.
Shelby, what'd you say 21 was? 1.578?
7.978.
Okay, sorry.
It's okay.
Yeah, 7978. Yeah, see, like this supply and demand of airline tickets. Did we already do this, or am I crazy?
We already did it, but
I should save my answers, like write them down, so I don't have to do it all over again.
So would this be dependent or independent?
I said dependent
I think it's dependent.
Okay.
because you're calculating the determine if there's a difference.
Yeah, that makes sense.
Would it technically be dependent as well, since it's the same flights?
So do you guys have the answers for 25?
I'm seeing if I have it written down. Like I have some notes from my on a notepad or whatever.
Well, has anyone calculated the answer?
Working
No.
on it.
Already. Well, I mean, I write this stuff down, but sometimes I throw it away. I don't know why I tear it out. Well, it's my wife's notepad, so anyway.
P-value of 1 point. What do I have wrong? Oh, it should
For
be
25 for the test statistic, I got 1.685,
yes.
and then the p-value is 0.096.
Yep.
And so then there's, for 27 is B, there is sufficient evidence to conclude that there is a difference in the cost of tickets.
Yep.
And then which one did we skip?
7, I think.
It was 6.
6, around there. All right.
So I went ahead and submitted it, and we got a couple wrong. Number 4.
Mm-hmm.
Number 4. What did you guys put for number 4? Did you put confidence interval for the mean of differences using dependent samples?
Yep.
That's not right.
Okay.
So I might go with independent samples or something else. Number 6.
It would be independent, right? Because they have no relation.
Yeah.
Hey guys, I actually have to go because I have another meeting at 6.
Okay.
So I'm just going to submit it.
Okay.
So good luck on the rest of it, but
No problem.
Brandon can help you with what's wrong, I guess.
Great.
All right. Thank you.
Yep.
Number 10.
What was number 6?
Oh yeah, all right, number 6. It was not 996.
Was it the 998040?
It doesn't say.
Okay. I think it's the 998040.
Yeah, I think. Yeah.
That's what I got when I did the math for it.
Yeah.
With the z-score being 1.96, and then you times that by the standard deviation, which is 2, the sample over the square root of the n, which is also, well, it's 4, and then turns to 2, so you just get 196, and then it's the 1000 minus the 1.96, and then also plus the 1.96.
Perfect. Boom. Shelby, are you still here?
Yep.
All right, guys. Number 10 is not the 60 GPAs. For number 10, we put yes. They have a total of 60 GPAs. That's not right. It's not the central limit theorem, actually, which I thought it was the central limit theorem, but maybe not. Hmm.
ANOVA testing is used to like compare means, so that would make sense why that's not ANOVA actually.
hmm The means have to be the lowest mean and the highest mean has to be no more than 4 times, right? Different.
Yes.
So can we even tell?
I don't
Uh,
think so.
well, because like it says, yes, it could be that the data is bell-shaped with no outliers, but I
I think
don't.
it's no that we don't have enough data.
I think
I'm gonna.
so.
I'm just gonna go with that.
Okay.
All right, number 12 is wrong. I put by reducing the probability of committing a type 1 error, we also reduce of type 2 error.
It's we increase type 2.
Yeah.
Oh, I put reduce. Ha.
I was
That's
gonna say, how did we get that one wrong?
Yeah, I was gonna say that one's right.
okay. Number 15, I put dependent sampling.
hmm
Which one?
The sister's academic achievement depends.
It was supposed to be
it's
that if you select a brother.
you must include the sister in in your study.
So I get these wrong even if you guys tell me the right answer. Good. All right. Well,
Was that the last one?
yeah, man, I got an 82. I don't know how it was a miracle. I got a 100 on my homework last Friday or Saturday. So anyway, yeah.
All right, looks like we missed 10. It's not that they don't have enough data,
Yeah.
but the rest is right.
Yep.
So,
Oh well.
oh well.
Alright, thanks guys.
Yep.
Have a good one.